I'd now like to hand back to Curig Johnston, who is going to host our panel for us to discuss AI. Is it a savior or a fraud? So over to you, Curig, and we'll bring in your guests for you.
Brilliant, thank you, Amy. So look, over the next 15 minutes, we'll aim to clarify the difference between AI and machine learning, discuss the problems it can help solve, and look at some of the sort of trends in the industry. If you've got any questions you'd like to add at any point, please ask through the chat function on Zoom, or also feel free to raise your hand and we can come to you to ask questions. Let me introduce the panel. So firstly, Maxim. Max is the Chief Technology Officer at Arloid. He has over 20 years of experience deploying large-scale software projects and now heads Arloid's R&D department. Supporting Max at Arloid is Alexander. Alex specializes in applying reinforcement learning, customer analysis, and deep learning algorithms. Next, we have Mark Moloney. Mark is currently engaged in edge computing, federated analytics, open AI platforms for machine learning, embedded products. He has been involved in multiple startups who are challenger organizations taking on global competitors, and he's worked for large organizations such as Telstra, leading the implementation of AI machine learning solutions at scale. And last but not least, of course, Vladimir, who we heard from just now, based in Singapore. Vlad is Arloid's Chief Product Officer and responsible for ensuring Arloid's AI aligns with customer needs while driving sales, marketing, and partnership efforts globally. So thank you all for joining and welcome. Look, I'd like to ask sort of the first question to Mark. We've got about, I think in total around about sort of 15 minutes or so. So sort of keep it running reasonably at pace. Mark, what kind of problems are suitable for an AI solution?
Thanks, Curig. So really having good data, or the means to collect or generate good data, is a key ingredient. AI looks for patterns in data. Therefore, if the problem is such that we can have historical measurements, or if we can simulate the environment, that's a pretty key requirement. So we use this data to train an algorithm to make a prediction or perform a decision-making task that would normally be done by a person. So the second criterion would be AI solutions are good and suited to the types of decisions that a person would make, but it's where the scale and frequency of those decisions would make the task either impractical or costly. I guess in conclusion, AI is not, or at least not yet, great at creative activities, although it's sometimes good at making connections that exist in the data, but otherwise obscured by the volume of data.
Brilliant, thank you. That's a really helpful answer, Mark. Now to Alex, you know, how will AI react on data it has never seen before?
Yeah, you can see me, yeah. Okay.
Yeah.
So yes, first of all, when we train our model, especially in the reinforcement learning, we face a problem which is called exploitation versus exploitation. And in this case, we force the agent, the model, to do what is called exploration. And in this case, what it means is, well, yeah, the picture is actually illustrating how the reinforcement learning is working. And what it means is by during the training of the model, while it forms the strategy, which the agent, in the case of what is shown on the picture, is the mouse, artificial mouse. When it forms its strategy, we'll make sure that it's seen as much as possible environment stays as it is possible or as it can. And eventually the trained model, which we'll have at the end, will see an enormous amount of possible environment states, and we'll learn the best actions to take in response to those. And this amount of possible states could even be much bigger than it is actually possible in the real life. Also, we check the performance on an independent data, which we did not use while we've been training. So that's how we also checked what the model is actually performing good and could generalize on a data like that. So yeah, that's generally this.
Okay, so that sort of refers to the reinforcement learning example, where effectively the machine has to, if you like, learn by trial and error, and because of, if you like, the cost of the initial setup, it's important to have that sort of simulation element that I know you guys have sort of implemented into your solution. Question for Max: what skills are needed to build AI applications?
I think that the first of all, you need good math skills. I mean, you need to have a good math background to build the application. And the second one is, of course, you need to be a good developer. Because at the moment, to build AI application is something in the middle of the math and the computer science. So that's why it's the one of the biggest problem of applying AI in the real sector is the people. Actually, yeah, AI is training, but it's really difficult to find right employees and the right people who get this background math and software development.
Thank you, Max. I've got a bit of a problem maybe with my connection. I'm just going to need to reconnect. Maybe we just ask briefly to Mark. Mark, would you like to sort of add anything on to that view? I mean, I know some of the conversations we've had around the operational aspects of AI, given the limitations.
Yeah, I guess there's been a lot of attention on the role of the data scientist, but what we're seeing is some supporting roles, particularly around how to acquire the data to support some of the activities performed by the data scientist. But there's a big focus now on how do we operate and get machine learning from the lab into a real world production environment. So one of those emerging roles is a role known as the machine learning engineer. This is someone who can build a factory that can efficiently run the algorithms and make sure that they perform safely and effectively and meet some of those non-functional requirements such as performance and reliability. So it's becoming much more of a village in terms of the different types of roles that participate in creating these solutions.
Thank you, Mark. I guess Curig is reconnecting to us. So
Okay,
maybe Amy, you will.
Yeah. So the next question. Curig is back with us, but the next question is actually to Alex about AI and how it will react to data that it hasn't seen before. And you touched a little bit on that. So maybe we've covered it if we want to go to the next question. Curig, are you back with us or not quite?
I am, sorry about that, sort of internet issues there. No, thank you. So, you know, I think if we talk about, have you talked about sort of the energy optimization point? I think there's a general point if we talk about energy optimization, very wide range of solutions that can help to achieve that, Vlad. Where do you see AI fitting in?
Yeah, so as you correctly said, yeah, there is a wide range of things that can be done with regards to energy optimization, and AI basically comes into the picture when we talk about the enhancement of systems that are already in place, or maybe even if the building is going for the replacement of a complete replacement, retrofitting, then they introduce super efficient devices and top-notch systems. Again, it all comes down to one thing on how you manage that, and then artificial intelligence is basically the way for to make all the systems that are part of the energy efficiency make it smarter. When we talk about the generation of power, so artificial intelligence can help here to understand the demands and like to match demand and supply. Then on another level is to on the management of things like HVAC infrastructure, as I was covering in my keynote presentation, and all other things that require, let's say, people's interaction with the system. And so in this case, it can be easily replaced by the artificial intelligence.
Brilliant, thank you. I mean, look, I think sort of going back, to the point around sort of the application of AI in real life. I mean, I'd just love to hear from sort of both Max and Mark. What are some of the issues that they see in the wild, if you like?
Okay, let me start probably. Mark already mentioned one issue is the lack of data, and usually when you try to apply AI in the real life, you face the two situations. First of all, you have no data at all, or the second situation that you have a lot of data, but you can rely on the data. So that means that you have a quality of data is really poor. And the second problem, it's also the main problem I also talk about, is about there is not enough skilled people for this. Usually the companies tries to apply AI and they tries to build own teams. And because it's really difficult to find really good people with both background like the math and software development, it's really difficult to build this team on site, and that's why there is some issues with the application of AI. And the second and the third problem, but maybe not the last, is that a company tries to partial approach for application AI. For example, they tries to automate maybe only one step in the process, and this raises a lot of gaps in the other way. So they automate only one step, and they need to continue the old version of their process in the lab. So that's why they didn't get expected results from application AI.
Brilliant, thank you, Max. Mark, do you want to build on that?
Yeah, I mean, Max has done a pretty good job at covering the core issues. Generally, the machine learning algorithm or component is just one small part of a larger system. So I think a lot of the challenges in building commercial AI is around a lot of areas that are quite common problems, such as how do we integrate it with other systems? How do we wrap safety guards around monitoring to make sure that we're continuing to check that the model is making good decisions or recommendations, and we've got this process of feedback to continually improve it, retrain it, keep it in check.
Brilliant, thank you. I'd also, Vlad, a question to you. Will AI apply the same logic for all building types, such as shopping malls, hospitals, office blocks, etc.?
Yeah, on the foundational level, I mean, it's going to be the same. So based on the reinforcement learning. So the key difference between the types of buildings come into like from the angle that in some buildings there is a heavy human traffic, which means that we need to rely on comfort indexes. And in our case, we rely on H555 standard. And then the artificial intelligence is tasked to satisfy this comfort index. But while when we go to data centers or let's say hospitals, it has like specific restrictions on humidity and temperature levels. So in this case, we don't rely heavily on comfort indexes, but rather go for the restrictions. And then the artificial intelligence is trying to navigate the best settings to comply with the available corridor. And also, even if we talk about the same building like office center or university campus, it might be a combination of two things, which is to apply the comfort index, since we have places where a lot of students are and like the serious people traffic, and also there might be some labs that require some restrictions with regards to the thermal conditions. And in this case, it's going to be combined. So yeah, there are variations, but on the foundational level, it's more or less the same. I mean, artificial intelligence is making the decisions, taking into account these restrictions. Yeah.
Great. So sort of the, if you like, the structure of the model, the tools, a lot of the foundational elements would be the same, but you'd be sort of targeting a different outcome effectively. So it will be learning to achieve a different outcome for customers. So a lot of reusable pieces, which is, no, that's great. Another sort of question is, what do you see, Mark, as sort of some of the key trends, current trends in AI at the moment?
Yeah, I mean, Alex has kind of previously mentioned reinforcement learning. This is a branch of machine learning that's certainly making its mark. A lot of traditional machine learning is about analyzing data offline to make predictions. Reinforcement learning takes this a step further, where it's involved in active decisions in a dynamic environment, and it's using feedback from the environment to learn in real time. So that has lots of new and interesting applications in areas such as self-driving cars and energy optimization. A second area is models are getting larger. So we're seeing more complex models that can handle a number of tasks. One of the areas where this can be quite useful is where we don't have a lot of data that might exist for a very specific task, is we can use some of these general purpose models that have been trained on industry data, and that learning can transfer so that we can apply it to our very specific situation by using the small amount of data that we have to fine-tune that model. And therefore we can start to bootstrap the capability, which otherwise would be difficult if a particular problem space didn't have a whole lot of data to start with. In general, AI is quite data hungry, so the techniques that allow us to use the data that we do have more efficiently is where there's a lot of interest, because that's expanding the scope that we can apply AI. Sorry, Curig, we've lost.
Sorry, Mark, thank you. No, they were great examples. So the sort of the reinforcement learning example is a really good one, where the system can start off with less data from a training perspective, and it sort of learns in the environment where it is. And your second example around sort of transfer learning, if you like, where you potentially train examples where you train on very large bodies of word, train a sort of natural language processing type algorithm, but then adapt it or apply it to the local, situation or dialect that you need to deal with, and that's a lot more efficient then than sort of training an entire model from scratch, right? So,
exactly.
Yeah. That's really helpful. Thank you. Look, sorry, we're out of time. I've got to hand back to Sergey now to conclude, but thank you very much all for your participation.